Hey everyone. In today's lesson, we're going to look at graphs of the sine and cosine functions. So to start with, I've drawn a unit circle on the left, and I've marked off the quadrantal angle measures. So on the positive x-axis, we have the angle 0 and 2 pi. The positive y-axis, we have the angle pi over 2. On the negative x-axis, we have the angle pi, and on the negative y-axis, we have the angle 3 pi over 2. And what I've done is I've marked the points on the unit circle that correspond to those angle measures. So at 0, it's the ordered pair 1, 0. At pi over 2, it's 0, 1. At pi, it's negative 1, 0. At 3 pi over 2, it's 0, negative 1. And then when we get back to 2 pi, completing that rotation around the circle, we are back to the ordered pair 1, 0. So if you guys remember back in the lesson on the unit circle, we defined the sine function as the y coordinate of the point on the unit circle. So what I've done on the left-hand side down below the unit circle in black is we are going to look at the sine function y is equal to the sine of x, and we want to identify ordered pairs that are going to go on the graph of that function. So our inputs for the sine function are going to be the quadrantal angle measures, and the outputs for sine are going to be the y coordinates of the point on the unit circle. So if we go to the angle measure of 0, the y coordinate at that point is 0, so sine's value at 0 is going to be 0, so that's going to correspond to the ordered pair 0, 0. If we go to the angle measure pi over 2, sine's value is going to be the y coordinate at pi over 2, which is 1. So the point on the graph of y is equal to the sine of x is going to be the ordered pair pi over 2, 1. When we go to pi, sine's value again is the y coordinate. So at the input of pi, the y coordinate at that point is 0. So that's going to be the output. So that's going to correspond to the point pi, 0. At 3 pi over 2, the y coordinate at that point is negative 1, so that's going to correspond to the ordered pair 3 pi over 2 comma negative 1, and we get all the way back to 2 pi. The y coordinate at that point once again is 0, so that's going to be the ordered pair 2 pi comma 0. And we can do the same thing for negative angle measures. If we go along the unit circle, negative angle measures are going to correspond to a counterclockwise rotation. So the radian measure 3 pi over 2 is going to be the same thing as the measure negative pi over 2. So negative pi over 2 is going to have a y coordinate of negative 1. Negative pi, which is going to be the same thing as pi, is going to have a y coordinate of 0. And then you can find the same thing for negative 3 pi over 2 and negative 2 pi. So what we can do then is we can take those points and plot them in a coordinate plane to take a look at the graph of the function y is equal to the sine of x. So when we plot those 9 points that we found, we're going to get those points plotted in that black coordinate plane, and then we can connect those points with a wave-shaped curve, because the graph of sine and the graph of cosine are sinusoidal functions, which means they are wave-shaped graphs, and we see that the graph of that sine function is going to look like that black graph from negative 2 pi to 2 pi. And something important for us to keep track of in this lesson is, you guys see the little acronym I have down below sine. The capital I's stand for intercepts. The capital M is maximum, and the lowercase m is going to be minimum. And if we start from the origin at the angle measure of 0, we're going to have, our graph is going to have an intercept. When we move over to pi over 2 radians, the graph there has a maximum, so I've denoted that with a capital M. When we move over to pi radians, it's an intercept. When we move over to 3 pi over 2 radians, our graph has a minimum. And when we move over to 2 pi, once again, the graph has an intercept. So it's intercept maximum, intercept minimum, intercept, and that's something that we want to keep in mind when we graph sine functions. We can do the same thing for the graph of cosine. On the unit circle, we define cosine as the x-coordinate of the point on the unit circle. So if we go to the angle measure of 0, the x-coordinate at that point is 1. So on the graph of y is equal to cosine of x, the input values are the angle measures. The output values are going to be the ratios that correspond to that angle. So that's going to be the ordered pair 0, 1. When we go over to pi over 2, cosine is the x-coordinate at that point. So the x-coordinate at the angle pi over 2 is going to be 0. When we move over to pi, cosine again is the x-coordinate, so the cosine of pi is -1, so that's going to correspond to the point pi -1. And then you guys can determine the ordered pairs that correspond to the other 6 points, just as we did with the sine function. Again, with cosine, we are looking for the x-coordinate to determine cosine's value at that angle measure. So when we take those 9 points and plot them in the green coordinate plane, we're going to get a graph that looks like so. And when we look at the graph of cosine, just like we did with the graph of sine, if we start at the angle measure of 0, we have a maximum at that point. So I've denoted that with a capital M. When we move over to pi over 2, we have an intercept. Moving over to pi, we have a minimum. Over to 3 pi over 2, we have an intercept. And then we move over to 2 pi, we have a maximum. So that's going to be the acronym that you want to know for cosine. It's maximum, intercept, minimum, intercept, maximum. And we're going to use those acronyms both for sine and cosine when we graph different variations and more complicated variations of those two trig functions. Okay, so moving ahead, there's a couple, oh, I'm sorry, let me go back. So in your guys' notes, like I made a note of like how we write the intercepts. So like for the graph of the sine function, we have intercepts at 0, pi, 2 pi, -pi, and -2 pi. And I wrote just a general form of those x-intercepts. It's going to be x equal to n pi, where n is an integer. So that formula is going to generate all of the x-intercepts for the sine function. And then when we look at the graph of cosine, that graph has intercepts at pi over 2, 3 pi over 2, -pi over 2, -3 pi over 2. That is all odd multiples of pi over 2, so we can denote that using the formula x is equal to 2n plus 1 times pi over 2, where n is an integer. 2n plus 1, where n is an integer, is going to produce like all of the odd values of pi over 2 for those x-intercepts. Okay, so the next thing we want to look at really quick are the amplitude and period of sinusoidal functions. So for amplitude, it says for sinusoidal functions of the form y is equal to a times the sine of bx and y is equal to a times the cosine of bx, the amplitude is the absolute value of a, which is the coefficient out in front of sine or cosine, which should make sense. If you guys think back to graphing with transformations, when we multiply out front of a function by some number, that's going to correspond to either a vertical stretch or a vertical compression, depending on the value of a out front. So it says when the absolute value of a is less than 1, so when the amplitude is less than 1, the graph is going to be vertically compressed. When the absolute value of a is greater than 1, the graph is vertically stretched. Okay, for period of sinusoidal functions, so for sinusoidal functions of the form y is equal to a times the sine of bx and y is equal to a times the cosine of bx with b greater than 0. Okay, so it's important that our b value is positive. We're going to take a look at, in a few minutes, an example where our b value is not greater than 0 and how we go about treating the function when that's the case. Okay, so the period is 2 pi divided by b. So again, when we multiply inside of a function, we know that that corresponds to either a horizontal stretch or a horizontal compression. So when the value of b is less than 1, the graph is going to be horizontally stretched. And when the value of b is greater than 1, the graph is horizontally compressed. So what amplitude refers to? Amplitude refers to the distance between like the midpoint of your graph and the maximum and minimum values. Or another way you can think of it is if you take the y value, that's the minimum, and the y value, that's the maximum. If you find the distance between those 2 points, so like for example, the graph of the sine function that we have up here, the minimum value is -1, the maximum value is 1, the distance between those two values is 2. If you take half of that distance, that's going to give you the amplitude for your graph. So the amplitude for that sine function is going to be 1. That tells us the distance essentially from the x-axis to the maximum and minimum values, provided that your graph is not shifted up or down, because if it's shifted up or down, it's not going to be relative to the x-axis anymore. Okay, what period refers to? Period refers to how long it takes for the graph to repeat itself. And when we look at both the sine and cosine functions, it takes 2 pi radians for those two graphs to repeat themselves. Okay, so the period for both sine and cosine are going to be 2 pi. Okay, so what we want to do really quick is take a look at an example where we're asked to graph a sample trig function. So we'll start with a pretty basic one to start with. So we have y is equal to 3 times the sine of 4x. There are a couple things that we want to identify right off the bat. So first thing we want to do is determine the amplitude. So the amplitude is the absolute value of a, which is the coefficient out in front of sine, which is going to be 3. And next we want to determine the period. So the way we determine the period, we use in math t to represent period. So the period is going to be 2 pi divided by the coefficient in front of x, which is going to be 4. So 2 pi over 4 simplifies to pi over 2. So that's how long it takes for that graph to repeat itself. Okay, what we want to do next when constructing our graph is we want to take the period that we calculated, and we're going to multiply that period by 1/4, and we're going to do that for 2 reasons. Number one is we're going to make ourselves a table to sketch the graph of these sine and cosine functions. So it's going to give us our incremental change in the x direction for our table. And also when we sketch the graph of this function, it's going to give us our scale in the x direction to help us scale our graph properly. So when we take pi over 2 times 1/4, that gives us pi over 8. Okay, so if we remember back to when we graphed the sine function originally, the acronym that we came up with for sine is intercept, maximum, intercept, minimum, intercept. So going to be IMIMI for short. So I'm going to write that down because that's going to help me plug values into the table that I'm going to create. So next thing we want to do when sketching the graph here is we want to make ourselves an XY table. And we're going to input x values into our XY table. So we're going to have 5 entries into our table. In this particular case, the first entry we're going to start with is going to be 0. The last entry for us is going to be what the period of our function is, which is pi over 2. And then the change in the x direction for us is going to be the period times 1/4, the value that we found over here, which is going to be pi over 8. So to go from one x value to the next, we're going to add that number to the previous value in our table to get the next value in our table. So if we take 0 and add pi over 8 to it, it gives us pi over 8. When we take pi over 8 and add pi over 8, that's 2 pi over 8, which simplifies to pi over 4. 2 pi over 8 plus pi over 8 is 3 pi over 8. And 3 pi over 8 plus pi over 8 gives us our last value, 4 pi over 8, which happens to be pi over 2. Okay, so to get the y values in our table, we're going to look at our acronym that we have up here. And that's going to tell us what our y values are going to be. So where we have intercepts, the y value at an x-intercept is going to be 0. So we're going to have y values of 0 at the first, third, and fifth entries. Our maximum value is going to be the second entry. So if the amplitude of our graph is 3, that means the maximum value on the graph of that function is going to be 3. And if the minimum occurs at the fourth entry, the y value at 3 pi over 8 is going to be the minimum value of our function. So if the amplitude is 3, that minimum is going to occur at -3. And once we have that, we have enough information to sketch the graph of the sine function. So we're going to label our tick marks in the x direction. So our scaling is going to be pi over 8. You only have to label that first one, but if you want to label additional values to help you plot points, that's fine. So this one here would be pi over 4. You don't have to label that though, because I know once you've labeled the scale of pi over 8, the next tick mark is going to correspond to 2 pi over 8, which is pi over 4. Okay, the next one is at 3 pi over 8, and the last one is at pi over 2. We're going to go up 3 units. So I'm just going to label my scale in the y direction to be 1. And then we're going to take the values from our table to plot points on the graph of this function. So our first point is going to be at 0, 0. Second one is going to be at pi over 8, 3. Third one is at pi over 4, 0. The fourth point is at 3 pi over 8, -3. And the fifth point is at pi over 2, 0. And then we're going to draw a sine-shaped curve, so a wave-shaped curve looking like so, passing through those 5 points like that. And then I'm going to continue, because I'm going to want you guys to draw 2 periods of this graph. I'm going to continue that same pattern to the left of the x-axis. So this point will be down here. The point at negative pi over 4 will be at 0. At -3 pi over 8 will be at 3. And then over here at negative pi over 2, we're back at 0. So that graph is just repeating that same pattern to the left of the x-axis. Okay, so that right there is going to give us 2 periods of the graph of that sine function.